Alright, hi Math 8. This is going to be notes number 28 on approximating square roots. The big idea for this notes, or set of notes, is to classify real numbers and how to approximate square roots. So we've somewhat already covered this in class, but I'm going to give you obviously a formal set of notes for that too. We're going to look at rational numbers. We got to look at what that means versus irrational. A rational number is a number that can be written as a ratio of two integers. And in other words, can it be written as a fraction? So an example of that is a whole number. A whole number can be written as a fraction because you could put it over 1. Or 2/3 is a fraction. 1/5 is a fraction. Anything like that is considered a rational number. Okay, irrational numbers, it's going to be the exact opposite. It cannot be written as a ratio of two numbers, or two integers, excuse me. The square root of any whole number that is not a perfect square is irrational. We just finished doing perfect squares and perfect cubes. If it's not perfect, it is irrational. It's an irrational number. So same thing goes for cubes, like I said. We're also going to be looking at decimals, and so the decimal form of an irrational number neither terminates nor repeats, meaning that this number, it doesn't stop, it keeps going. So we talked about pi. Pi is 3.14159, and it goes on and on and on and on. That's considered an irrational number, and it does not repeat. Okay, so there's no patterns. So rational and irrational numbers are two types classifications of real numbers. Okay, so rational numbers and irrational numbers together form the set of real numbers. So here's a Venn diagram, or a diagram I should say, of the difference between rational and irrational. Irrational is easier to look at. Like I said, it's a number that keeps going on, it doesn't stop, or there's no pattern, it's not perfect. The radical 2, for example, what number times itself is 2? That's going to be an irrational number. Pi is irrational, so anywhere you see pi here, it's going to be irrational. Cube root of 7, what number times itself 3 times is 7? That's not going to be a perfect number, a whole number, for example. Okay, rational numbers include natural numbers, whole numbers, integers, and rational as a whole here. Notice here how we have 0.3 repeating. This line right above the 3 means that it is repeating, so it's 0.3333. This means that it never ends, but because it's the same thing over and over again, there's a pattern to it, this is considered a rational number. This decimal here, 2.25, it stops. There's an end to it, so that means that this is rational. Negative 2/3 is rational, 1/2 is rational, and integers are both positive and negative numbers. Whole numbers is obviously just a whole number, 0, 1, 2, 3, and so on. Natural numbers are positive numbers, I believe. I could be mistaken, class, I'm not too sure, but these numbers here, because they are whole numbers or integers, positive and negative, they can be written as fractions that have an end to them. They are considered rational numbers. Okay. Example 1 is literally just looking at different types of numbers and classifying them. So we have radical 12 here. We have to think, is the square root of 12, meaning a number times itself to equal 12, is that going to be a perfect number, a whole number, for example? Well, because 12 is not a perfect square, and you guys should know that, we did our perfect square quiz the other day, it is irrational. Okay, let's take a look at B. Excuse me, guys, I got allergies. It's not the virus, don't worry about that. I've been cleaning my house, so I have a lot of allergies today. Negative 0.25 repeating. So this line above the 0.25 is saying that it repeats negative 0.25, and so on. Because there's a pattern to it, this is going to be rational. It's a repeating decimal. Okay. The negative square root of 9, or is going to be an integer as well as rational, because what number times itself is 9? Well, hopefully by now you know that's 3, so the answer is going to be -3. Opposite of that, so -3. So it's equal to -3 because it's a whole number that can be written as a fraction. This is not only a rational number, but it's specifically an integer. It's a negative number. Okay. And then D says 72/4, or 72/4. If I were to put that in the calculator, 72 divided by 4, I'm going to get 18. So that obviously is a whole number. It obviously can be written as a fraction too. It could be written as 18/1 as well. This is a natural number, a whole number, an integer, and it's a rational number. So this one is a special type of number, and it has 4 different categories. Okay, and pi we've already discussed is irrational. The decimal form neither repeats nor terminates. So there's no patterns and it does not stop. It continues on forever. All right, so that's the first page, class. Let me go to the next page. The next page, we're dealing with example 3, comparing real numbers. So now, I'll be honest, guys, this is a little more complicated. I think a lot of you will do better with this if you just guess and check, you're playing around with the calculator, but I'm going to show you the way that the book shows it to you, so that when you look at the textbook you'll understand what's going on there. It says, which is greater, radical 5 or 2 2/3? Well, we did this last week when I showed you the PowerPoint. We're going to figure out what number is closest to the square root of 5. So we're going to estimate it to the nearest integer, in other words, the nearest number. Then we're going to graph it, but I didn't graph it, so don't worry about that. You can if you want, but I know that some of you don't like doing that. So what number is closest to the square root of 5? So we got to think about the perfect squares. So I know 1 is a perfect square, 4 is a perfect square, and 9 is a perfect square. So this is the square of a number. 1 squared is 1, 2 squared is 4, 3 squared is 9. So I know that the square root of 5 has to be in between radical 4 and radical 9. So in between these two numbers here. If I had a radical here or a square root, same thing here, radical or square root, depends what you like to call it. I know the number is going to be closer in here, but is it closer to 4 or is it closer to 9? Or the square root of 4 or the square root of 9? Well, hopefully you see that this is only 1 away, so it's going to be closer to the square root of 4. But the square root of 4 is 2, so I know my answer is going to be about 2. Okay, and what's kind of interesting is that we're dealing with 2 2/3. Well, some of you may know this, but if not, you can use a calculator. Do 2 divided by 3 in your calculator, and it's going to give you 2 2/3. But 2/3 as a decimal is 2 2/3 is 2.6666. It goes on and on and on forever, including this 6 here. So if I were to round, it'd be about 2.7, okay, to the nearest tenth. But the thing is, we don't know how close radical 5 is to being 2.7. I can make a good guess in guessing that this is going to be larger, which it is, in fact, larger, because radical 5 is about 2.2. One thing you can do, class, is just guess and check. So you can do it to the nearest tenth. You could do 2.1 squared, and you're going to get a number. But 2.2 squared is 4.84, and that's pretty close to being 5. 2.3 squared is 5.29. You can see you're already over 5 here. It's closer to 2.2. So that's how I knew that radical 5 is about 2.2. And to be honest, guys, it's just guessing and checking. If you're given a calculator, that's what's really neat about it, is you can just guess and check to see what's closer. But unfortunately, you may not be given a calculator on this. You're just going to have to go to the nearest tenth. So I would start with 2.1, do 2.1 times 2.1, find out what that number is. You're going to see it's going to be under this, obviously. But then 2.2 times 2.2 gives me this number. You can just do it off to the side if you have to. And then 2.3 times 2.3 is 5.29. So obviously it's closer to this one. That's how I knew it was about 2.2. 2.2 is obviously less than 2.7. This is about 2.7, okay, or even 2.6. It's still smaller than that. So 2 2/3 is larger, okay. I have here, guys, these on your own problems. This is from the textbook as well, but I'm going to ask that you try your best. Your work can be either like this, it could be like what we've done in class. You could do a number line, you could do this, guessing and checking. It's all up to you guys. I just want to see some thought process here on what number you think is bigger. I want to see your work. Please either take a picture of this or type in your work into the Google Slides that I have for you. I would like you to do these notes here, but honestly, class, I know you have a lot of other work to do from your classes, so I'm really just going to be checking for the practice. I want to make sure that you're actually engaged in doing work in class. If you have any questions, please let me know, but yeah, try to post a picture or type in your answers into the Google Slides. I hope you guys are doing well. If this is helpful, I will continue to do it. If not, please let me know, because I don't want to waste your time, obviously, or waste time when I could be doing, giving you other resources that would help you. But again, I hope you guys are doing well. I miss you guys. Keep up the hard work, and again, ask me any questions if you have any.